Hello everyone, this is Professor Chan from Math 1245 speaking. Today we're going to be going over section 4.4. 4.4 will be quite a long section as there's multiple parts to it. One thing too is when you are doing 4.4, make sure you understand 4.3, which is the properties of logs. Okay. So 4.4 is why do we use the properties of logs? Because it's going to help us solve logarithmic equations, okay, and exponential equations as well. Now, in 4.4, there are four different types of logarithmic slash exponential equations. This video, we're probably just going to do the first two types, okay? So, one of the things too is sometimes you have problems which could have more than one way of solving it, okay? So as we kind of do all four methods, you could see certain problems where you can do different ways, okay? So, section 4.4, let's talk about it. So one way we can solve is what's called change of bases, okay? So if you remember back in section 4.2, we had this rule where if I have the following, if I have u is to the a is equal to u to the b, that means a would be equal to b, okay? So let me explain what that means, right? If I have two things that have the same base, which happens to be u, right, and they have different exponents, and they're equal to each other, that means the exponents have to be equal to each other as well, okay? So the idea is what I can do is I can change my bases so that I have the same base and then use the exponents to set them equal to each other. Okay, so let me show you example like number 1. So I have 2 to the x is equal to 64. One thing I realized is I could take 64 and manipulate this into a power of 2. Okay, so 64 is going to be equal to 2 to the 6. Okay, here's the thing. If you don't remember, that's okay. Just do the following. Where just type it in, right, and see if it works. And it does right here, okay? So you just keep plugging it in until you get it if you forgot certain powers, okay? So then you realize this is just x is equal to 6. You see that because they both have the same base. So that means their exponents must be set equal to each other here, okay? Okay. So same thing for number 2. This will become 3 to the x, and I realize 84 is 3 to the 4th power, so that means x has to equal to 4. Okay. Now, as you can see with some of the problems towards the end of this page, some of these can get pretty tricky. Okay, so let's talk about this for the following. Okay. So, okay. So for example, let me look at number 4. Okay. So number 4, let's take a look at this. I can clearly see they're not the same. Okay, so I want to change both of them because 8 is nothing. I cannot change 8 so that it's a base of 4. There's no way that's going to happen, right? Because if I do 4 squared, that's 16. That's too large. Okay, so let's do the following. So I realize what is 8? 8 can be the same as 2 to the 3rd. And then 4 is the same thing as 2 squared. Now, if you notice, I have a power to a power, so that means I'm going to multiply it out, right? So this will become 2 to the 3 times 1 minus x is equal to 2 times 2 to the x plus 2. So I'll set my exponents equal to each other. Okay, and then once I distribute, this just becomes a regular algebra problem. So then all I'm going to do is I'm going to plug it in. Sorry, not plug it in. I'm going to solve for x. So I'm going to add 3x on both sides. So I have 5x is equal to -1. And I have x is equal to -1/5. Okay. One thing too is if you plug them back in, okay, you should get the same answer for both. Okay, so you can also check by plugging them back in. Okay. Let's do one more. Let's look at number 3 here. Yeah. So just remember, I wanted to do this one just so that you guys didn't forget. But remember, if I take the square root of 7, remember that's the same thing as 7 to 1/2. So now I'm going to do the following here. Sorry, let me kind of sketch this out so we have room. So this will be x minus 2 over 6 is equal to 1/2. I'm going to cross multiply. So this is 6, 2 times the quantity x minus 2. 2x minus 4 is equal to 6. 2x is equal to 10. Divide both sides by 2, and I have x is equal to 5. Okay? So that's pretty much it. So the first type of method was called change of bases. So you want to manipulate it so both of them have the same base, and then you set the exponents equal to each other. Okay? Make sure, as you can see in problem 4, make sure you know your rules of exponents. So if I have a power to a power, remember I multiply them to each other together. Okay, let's continue on. So let's talk about the second type of situation here. Okay, so like exponents, if I have the same base for log, okay, so let me write this out. If log base a of m is equal to log base a of n, that means m has to equal to n as well. Okay. So this is really nice. So if it's one single log on both sides and they both have the same base, then obviously the item above that, they'll be equal to each other. So it's very similar with the same rule we had before. Okay. So let's talk about this right here. Okay. So when you're solving a logarithmic equation, okay, remember there's a lot of things you can do, right? So remember you can do the swap rule from section 4.2. Okay. So let me show you this from problem 1. So let me zoom in. Okay, there we go. Sorry, my apologies. So if you want to look at your stuff and it was too small to see, let me just show you. So pause right here for number 1 and 2. Then pause for number 3 and 4. So this is for 3, and then this is for 4. Yeah, so just pause that and then enter that in. Okay, and if you have questions, feel free to send me an email. Okay. So let's take a look at number 1 here for log base 4 of x. Okay, so remember, we've done this before. So remember, there's 2 ways to go about it. You can do the swap game, right? Where the base stays the same. You switch these two. So this becomes 4 squared equals x. Okay, so make sure you remember that, right? Your x and 2 will swap. The 4 will stay the same, but then we lose our log, and it'll be 4 squared equals x. So x is equal to 16, okay? Now remember this, okay? Here's a thing, right? If you do not like that method, let's talk about this here. I can do this like the following, where what I do is, remember, I can do the cancellation method, which is I will sneak a base 4 underneath because I have a base under my log at the same time. So remember, 4 to the log base 4 will cancel out, right? So I'm left with x. But remember, I have to do the same thing to the other side, so it's 4 squared, and I get the same thing, which is x is equal to 16. Okay? So whichever one you're more comfortable with, do that. Okay? But yeah. make sure you know, at least you know either one. Okay, whichever one you're more comfortable with, do that. I'm not going to force you to do a particular one. Okay, so you can either do the swapping method, right, or you can do the cancel, or you can do the properties of cancellations, right? So for the following. Okay, so let me show you something like number 2 here. Okay, and some of these can get really complex and long. So let's take a look at number 2 and see how this works, okay? So here's the situation at hand, right? I have 2 logs, so I can't really do the swapping game or the cancellation game. However, I do notice they have the same base. So what I'm going to do is, since they both have log base 3 as addition, remember back in section 4.3, we're going to do product rule. So it's going to look like this now. Log base 3 of x plus 1 times the quantity x plus 4 is equal to 2. You see that? So I'm multiplying it out for the following. Now, I don't need to actually multiply it out yet, okay? You can if you want. I'm going to wait till later. I just want to do the swapping method, so it's going to do the following, right? So I'm going to take these two and kind of move them around. So it's going to look like the following. Okay? You don't have to literally circle and then put arrows. I'm just showing you what's happening. Okay? So I have the following here. Sorry, let me erase the log, right? So when I swap, the log goes away. And I have 3 squared equals x plus 1 times the quantity x plus 4. Okay? So from here on out, this is just a normal mathematical problem. So I have 9 is equal to, and I'm going to distribute, right? So I have x squared plus 4x plus x plus 4. So I have x squared plus 5x plus 4 is equal to 9. And subtract 9 on both sides, right? So I'm solving this quadratic, okay, for the following. So what I'm going to do is I'm going to use the quadratic formula because I can't factor, okay? And this is going to be something that's going to be kind of annoying when you're doing these, because when you're doing these log problems, sometimes they're going to come out really simple. And then sometimes you may have to do factoring. Sometimes you may have to do quadratic formula. Sometimes you may have to do kind of rational expressions or essentially complicated fractions. So you have to make sure you know kind of like all the fundamentals, right? Because otherwise you're just going to be stuck for the following. So I realized I need to do quadratic formula. So this is -5 plus or minus square root 5 squared minus 4 times 1 times 5, right? All over 2 times 1. So this is equal to -5 plus or minus square root of 25 minus 20 over 2. So I really have -5 plus or minus square root of 5 over 2, which is -5 over 2 plus or minus square root of 5 over 2. All right, I'm splitting them up. Okay? So, right, so I have 2 solutions. The thing I have to be a little bit careful about is just because I have an answer doesn't necessarily mean they are correct, okay? So one of the things, let's talk about this beforehand. So one of the things we want to be mindful about is this aspect here, right? So I have 2 logs, and remember, logs have a restricted domain, right? Logs domains are generally from 0 to infinity. Now remember, log of x plus 1 goes to the left by 1, so my domain is -1 to infinity. This one here is -4 to infinity. Okay? So yeah, just kind of take a step back. But those are my 2 domains, okay? So my answer has to coincide for both domains. Okay? So, for example, let me explain to you. So, for example, if let's say if x is -3, it's not going to work because even though it fits in between -4 and to infinity, -3 wouldn't fit into -1 to infinity, right? Because -3 is smaller than -1, so it doesn't fit. So my answer must be inside both domains in order for it to work. Okay? So, let's look at the following here. So I'm going to check using my graphing calculator. Let's see what they are, right? So I'm going to do -5/2. I'll put that in parentheses just to be careful. Plus square root of 5 divided by 2. Okay, so this is -1.38. So that is actually too small. So we're going to cancel that out. So that one doesn't work. And then this one, so let me do minus, will actually not work because it is -3.61. That is also too small as well. Okay, so even though both of them, let's talk about this. So even though both of them for the following work for the x+4 domain, it doesn't work for the x+1 domain. So it doesn't work. So surprisingly, we actually have a no solution. Okay, and that is possible for the following. Okay, so why? Because both of them fall outside of both domains. Okay, so let's continue and let's practice some more. So let's look at something like the following here. Okay, so let's look at something like number 4 here for the following. Okay, so we're going to do the following here. Now, here's the thing, right? I have 2 logs on the same side, right? This is not helpful. I want just 1 log. At most, I want 1 log on each side. So I have 2 here. I realize, though, I have the following. So I can write this as log of a, and I do x minus 1 over x plus 6 equals log a x minus 2. So remember, because I am subtracting, I can divide. I'm doing division right here. Okay. So here's a situation at hand, okay? So notice we have 2 logs, right? 1 on each side of the equation. If I scroll back up, right, the rule is if I have log base a of m and log base a of n, right, the 2 objects that are propped on top of the logs will be equal to each other. So if I look down here, notice they have the same base. They have the same base of a. It's going to be x minus 1 over x plus 6 is equal to x minus 2. Okay. So let's talk about how we solve this. We remember, if I have a fraction, I want to get rid of the denominator. So I'm going to multiply both sides by x plus 6. I'm going to distribute this. So I have x squared plus 6x minus 2x minus 12, x minus 1. So I have x squared plus 4x minus 12, x minus 1. And I'm going to move it over. So this becomes, I'm going to add 1, and subtract x. So I have x squared plus 3x minus 11. Okay. Before we start solving, I do want to look at my domain. So I notice my domain's from 1 to infinity. This one's -6 to infinity. And this one is 2 to infinity. Okay. So remember, our answers must fall into all three of these. So any number that's below 2 is essentially wouldn't count. Okay. Unfortunately for us, we have to use quadratic formula once again. Okay, it will happen. So I have negative b, which is -3, plus or minus square root 3 squared minus 4 times 1 times -11 all over 2 times 1. Let's simplify this. So this is 9 plus 44 over 2. This is -3 plus or minus square root of 53. Okay. So my two answers is -3/2 plus square root of 53 over 2, and -3/2 minus square root of 53 over 2. Okay. Now here's the thing. Before you even put in your calculator, you can immediately tell the negative one won't work, right? Because minus and minus is obviously negative. And my two domains I have is 2 to infinity and 1 to infinity, so obviously that one won't work. Okay. But let's try the first one. So I have -3/2 plus square root of 53 divided by 2. And I get 2.1400. So it actually makes it in, right? 2.1 fits in all three. So this is my final answer. Okay. One thing, be really careful with your with your answers. In MyMathLab, sometimes they'll ask you to write it in its radical form. So you'll write it like that, or they'll say write it to the nearest 10th or 100th. So you'll convert it as a decimal. Okay. Let's see which ones we can do. Okay, so let's look at something like number 8. Okay, yeah, and some of these are gonna get pretty tricky. It is bound to happen. So let's look at number 8 here. So once again, I realize that I have a lot happening, right? I also realize I have 2 logs on one stage, okay? I am actually not going to move the log over, okay? Let's talk about why. Because the problem is I have this -1 in the log, and then remember the log has to be by itself. So this -1, the problem is if I move it here, right, or if I move the log over here, the -1 kind of messes everything up. Because remember, in order for the logs to work, it has to be just the log, right? It can't be like log x and then +1 afterwards. Okay, so sorry, let me erase that. So what is my strategy? My strategy, once again, is to combine my two logs. So notice it's minus, so that means I'm going to divide it. It's going to look like this. Okay, we're going to swap. So remember how we swapped this one. Okay, this is going to swap with the following here. So this ends up being 1/3 to the -1 is equal to x squared plus x over x squared minus x. Remember, -1/3 to -1, it'll flip around. Remember, it's going to swap. So it's going to be 3. So we're going to multiply both sides by x squared minus x. So this is going to cancel. I have, and I'll distribute. This will be 3x squared minus 3x is equal to x squared plus x. I'm going to subtract x squared and subtract x. So I have 2x squared minus 4x is equal to 0. So the nice thing for us, right, is this one we don't have to do quadratic formula. We can just factor it. So I can pull out 2x. Okay. And I set both of them equal to 0, so I have x is equal to 0, and I have x is equal to 2. Okay, now, if I look at my domains, right, let's talk about this, right? So if I look at my domain, this isn't very obvious what my domain for both of these are. So, but I can kind of graph it. So remember, we can do change of bases now. So if I want to graph it, I'll do log of x squared plus 1. And then I divide it by log of 1/3. So I'm going to graph that one. I want to see kind of where my domain is. Okay, so it's actually, surprising enough, it's actually looks like it's all real except for, oh no. So it actually works for, this log is surprisingly actually has both. Okay. So this one is negative infinity to infinity. Let's see if the other one works too. So I'm going to go back and I'm going to do x squared minus x. Or sorry, x squared. Oh, okay. Sorry about that. Let's graph x squared plus x. Okay. So, interesting. So this one here, sorry, my bad. Let me redo this. Still a very wide domain. My domain for this one is negative infinity to negative 1, union 0 to infinity. So unfortunately for us, 0 doesn't work. Okay, and then let me graph the x squared minus x. Let's see what happens here. Okay, that one looks like it's from negative infinity to 0. Union 1 to infinity. But 2, as you can see, 2 works for both. So it fits in both domains. So that one works as well. Okay. Yeah, try to hang with me. I know these are a little bit tough. Okay. So the way your strategy is, right, you want to try to get rid of all of your logs, right? And then the second part is you solve x normally, right? And then make sure you find your domain, okay? So I think the situation at hand is for people who are doing these types of problems, the thing that is trickiest for these log problems is some people have problems getting rid of their logs, okay? And the second part is whether you can do quadratic formula or getting rid of kind of crazy fractions or factoring, okay? So you have to, if you're struggling with this and when you're doing your homework, kind of see kind of where you fall. Do you have problems with dealing with the logs themselves, right, for these types of problems? Or do you just have problems with like the second half, which is like whether it be quadratic formula or other things? Okay. Let's look at, actually, you know what? Why don't we stop here? We're going to come back, and then we're going to continue on with section 4.4. Okay. But other than that, have a good day. Just keep practicing. And once again, if you have questions, let me know. Other than that, I'll see you guys.